Good day, fans. Welcome to Dominic Academy. In today's class, we want to look at engineering mathematics, and the topic that we want to look at is trigonometry identities. So let's see. So what is the meaning of trigonometry identities? These are identities that relate the trigonometry functions like the sine, the cosine, the tangent, and so on. So in this case, let's look at some of the identities that you know already. So we have let me use this quadrant. This is a quadrant, and if you move from this point a unit, that is 1, and we have angle theta here. So we have here. So you can call here to be distance between here and here is A, while you move from there to here 1 unit. Then the distance between here and here can be called B, because we don't know that one. All right. So in this case, we know that sine. I want to use SOHCAHTOA, and this is SOHCAHTOA. All right. This one means sine equals to opposite over what hypotenuse. So we now have sine theta. We now equals to what opposite is B. The side which this angle is facing is what we call the opposite. This is the B. We have B all over. Then the hypotenuse is this side, the longest side, and the side has a value of 1. So we have 1 here. So B divided by 1 is going to give us B, right? That is for sine. Then for cos theta, that is cosine, right? For cos theta, we do the same thing. For cos, this is car. This is car. Car here means adjacent over hypotenuse. So let's see, this is adjacent. The down part here is the adjacent, which is A, over H is this one now, the longest side, over 1. So we have A. So it means that cos theta equals to A. We understand. Cos theta equals to A. So let's look at for tan theta. For tan theta, we have that one is what? Opposite over adjacent. This is opposite, this is what? Adjacent. So it's going to be B over what? Over A. So that is for this one now. Then we proceed. All right. So when you find the inverse of sine, you are going to have another identity. So inverse of sine here, or the reciprocal of sine, is going to be 1 over sine theta is going to give us what? Is going to give us cosec theta. 1 over sine theta is going to give us cosec theta. That is the inverse of sine theta. Then the inverse of cos theta is going to give us, that is inverse of cos theta. Cos theta. This one is going to give us what? This one is going to give us sec. That is secant theta. Sec theta. All right, we are done with that. But let's look at another thing. Let's remember this is a right angle triangle. So we can apply Pythagoras theorem. Yeah, so let's see. AB, this identity, this also identity, this identity, this identity, this identity, this identity. All right, so let's see. A square, when we apply Pythagoras theorem, plus B square equals to 1 square B. All right. So what next should we do? We look at this. A is what? What is your A from here? Your A is cos theta, right? So where you have A, you replace it with cos theta. So we have cos. Since A is square, you have cos square theta plus B is what? Your B is sin theta. So we have b, I'm sorry, we have sine square theta equals to 1 square is 1, right? So we have cos square theta plus sine square theta equals to 1. This is also an identity. This is also an identity. It's very simple for this. This identity also is also identity. We have this. So remember, if you want to work with cosec square theta, cos square theta, you can make cos square theta the subject. So this can also equals to 1 minus sine square theta. Then if you want to work with this one, you can have sine square theta equals to 1 minus cos square theta, and so on.